March 15, 1944, Foggia, Italy. 9:30 hours, Oberst Werner Baumbach, 31, Luftwaffe bomber commander and recipient of the Knight's Cross, examined a captured American bombsight, retrieved from a downed B-17. The device sat on a table in a converted villa that served as German intelligence headquarters. Metal and glass, gyroscopes and gears, all precisely manufactured to tolerances German engineers recognized as exceptional. Baumbach had heard the claims. American bombardiers bragged they could drop bombs into pickle barrels from 20,000 feet. German intelligence dismissed this as propaganda. But Baumbach was looking at the mechanism that supposedly made such accuracy possible. What he discovered over the next 3 days wouldn't change Germany's strategic situation. By March 1944, the Luftwaffe lacked resources to respond, even if they understood American bombing technology completely. But what Baumbach learned explained something that had puzzled German commanders for months. How did American bombers, flying through flak fighters at 4 miles altitude, consistently hit targets German bombers missed from half that height? The answer wasn't courage or training. The answer was engineering. Systematic, expensive, ingenious engineering embodied in a 50-pound device that cost more than some aircraft. By early 1944, strategic bombing had become the decisive air campaign of the European war. The combined bomber offensive, British by night and American by day, targeted German war production, transportation, and fuel supplies. But British and American bombing philosophies differed fundamentally. The Royal Air Force flew night missions, dropping bombs over general target areas. This area bombing approach assumed precision was impossible at night. Success meant hitting the right city. The exact buildings destroyed within that city were secondary. This philosophy produced devastating raids on Hamburg, Dresden, and other German cities. But it didn't destroy specific factories or rail yards with certainty. The United States Army Air Forces flew daylight missions using formation bombing with precision bombsights. This approach assumed that formations of bombers, each equipped with Norden bombsights and dropping simultaneously when the lead bombardier released, could destroy specific targets. Factories, refineries, marshalling yards, bridges, not cities, but the specific structures within cities that mattered militarily. The Norden bombsight, developed by Carl Norden beginning in the 1920s, was extraordinarily sophisticated for its era. It was an analog computer that calculated the trajectory from aircraft to target, accounting for altitude, airspeed, wind, and bomb ballistics. The bombardier would acquire the target through the sight's telescope, input current conditions, and the sight would calculate the precise release point. More remarkably, the Norden could control the aircraft during the bomb run. Through autopilot connection, the bombsight made fine adjustments to the aircraft's course, ensuring precise alignment with the target. This allowed bombardiers to make last-second corrections that pilots couldn't execute manually with sufficient precision. The device was treated as America's most closely guarded secret. Bombardiers swore oaths to protect the Norden with their lives. When not in use, Norden sights were stored in vaults. Before missions, they were installed in bombers under guard. If a bomber was shot down over enemy territory, bombardiers were instructed to destroy the sight before bailing out. Security measures rivaled those for atomic weapons. The secrecy created mystique that exceeded reality. American propaganda claimed Norden-equipped bombers could hit targets with near-perfect accuracy. The famous phrase was dropping bombs into a pickle barrel from 20,000 feet. Under ideal conditions, in peacetime testing over the American Southwest, this wasn't entirely false. Skilled bombardiers in the clear desert air did achieve such accuracy occasionally. Combat conditions differed profoundly from New Mexico test ranges. At 20,000 feet over Germany, bombardiers faced factors that degraded Norden performance substantially. Smoke from previous bombs obscured targets. Clouds covered objectives. Flak exploded around aircraft, forcing evasive maneuvers that broke the steady approach Nordens required. Fighter attacks disrupted formations. Equipment froze in temperatures reaching -40 degrees. Oxygen deprivation affected judgment. Fear and fatigue compromised concentration. Under these conditions, American bombing accuracy was nowhere near pickle barrel standards. In 1943, the average circular error probable, the radius within which half of all bombs fell, was 1/200 feet for American daylight bombing. This meant half the bombs dropped landed more than 1/200 feet from the aim point. Many missed by far greater distances. Some bombs landed miles from intended targets. This accuracy was still significantly better than German bombing without equivalent bombsights. Luftwaffe bombers using conventional bombsights achieved SEPs of 2,000 to 3,000 feet under similar conditions. So American bombing was more accurate than German bombing, but not remotely as accurate as propaganda suggested. When Baumbach examined the captured Norden in March 1944, he understood both the device's sophistication and its limitations. His report, recovered from German archives after the war, provided professional assessment without the propaganda that surrounded the Norden from both sides. The American bombsight represents exceptional engineering applied to bombing precision. The gyro-stabilized platform maintains reference orientation regardless of aircraft attitude. The mechanical computer solves ballistic equations continuously. The optical system provides magnification, allowing target identification from high altitude. Integration with autopilot allows corrections during bomb run impossible with manual control. These features explain American ability to hit targets we cannot reliably strike from comparable altitudes. Baumbach's report continued with honest analysis of limitations. However, the device cannot overcome fundamental constraints of high-altitude bombing. Cloud cover prevents target acquisition. Smoke obscures aim points. Aircraft evasive maneuvers disrupt the stable approach required. Equipment operates at theoretical limits in combat temperature and vibration conditions. Most critically, formation bombing requires all bombardiers to release when lead aircraft releases. Only the lead bombardier uses the Norden fully. Other bombardiers merely match lead's release timing. Thus, formation accuracy depends on one bombardier's skill and his aircraft maintaining perfect position. This last point was crucial. In American formation bombing, typically only the lead bombardier of each squadron actively used his Norden. The other bombardiers in that squadron watched for the lead aircraft's bombs to drop, then released their own bombs. This simplified the problem of coordinating simultaneous release. But it meant most Nordens weren't actually aiming. They were just very expensive bomb release. Timers, the report concluded with recommendations. Germany cannot produce equivalent bombsights in quantities needed given current industrial capacity and strategic situation. Attempting to copy American design would require resources and time we do not possess. More practical approach is improving fighter defenses and industrial dispersal to minimize damage from bombing, regardless of accuracy. American bombing accuracy advantage exists, but is not decisive. German war production continues despite bombing campaign. This situation will persist only if we maintain fighter defenses, preventing bombers from achieving optimal bombing conditions. Baumbach's assessment was accurate in early 1944, but by late 1944, American bombing accuracy improved as the 8th Air Force gained experience and German fighter defenses collapsed. With fighters unable to disrupt bomber formations and flak batteries running low on ammunition, American bombers could make steady, undisturbed runs using Nordens to full capability. SEPs dropped to 600 feet by late 1944, a significant improvement, though still far from pickle barrels. The psychological impact of Norden propaganda exceeded its tactical impact. German soldiers and civilians believed American bombers could hit individual buildings with certainty. This belief created fatalism that accurate assessment might have reduced. In reality, American strategic bombing destroyed German war production through cumulative damage. across many raids rather than surgical precision in individual raids. The Norden's real contribution was consistency. It allowed American bombardiers to hit approximately the same area repeatedly. Not the same building every time, but the same factory complex, the same rail yard, the same section of refinery. Over weeks of repeated bombing, this consistency ensured eventual destruction of all structures within the target area. It was precision through repetition, rather than precision through individual accuracy. After the war, bombing surveys analyzed American daylight precision bombing effectiveness. The conclusion was nuanced. Strategic bombing significantly degraded German war production, though not as completely or quickly as bombing advocates claimed. The Norden bombsight contributed to this effectiveness, but weather, tactics, fighter escorts, and overwhelming numbers of bombers mattered as much or more than the bombsight itself. German engineers who examined Nordens captured throughout the war consistently praised the device's engineering while questioning whether the enormous expense justified the accuracy. Improvement over simpler sights. This reflected different philosophies. American industry could afford expensive precision instruments for every bomber. German industry prioritized quantity over individual unit sophistication. Neither approach was clearly superior. Both worked within their nation's industrial capabilities and strategic contexts. One captured German. Assessment from late 1944 expressed the broader lesson succinctly: American. Norden bombsight represents their systematic approach to warfare. Significant resources applied to incremental improvements that provide marginal but consistent advantages. Our forces achieve local technical superiority in specific weapon systems. Americans achieve overall systematic superiority through good enough solutions produced in overwhelming quantities. The Norden is not a wonder weapon, but 10,000 B-17s each equipped with good enough bomb sights drop far more tonnage on target than 1,000 superior German bombers lacking equivalent precision aids. In war, adequate systems deployed broadly beat superior systems deployed narrowly. This observation extended beyond bomb sights to American war production generally. The United States didn't always produce the absolute best weapons, but they produced good weapons in quantities that overwhelmed opponents. The Norden exemplified this approach. It wasn't perfect. Under combat conditions, it delivered far less accuracy than peacetime testing suggested. But it was good enough, and America put one in every heavy bomber. Today, precision-guided munitions achieve accuracy measured in feet rather than hundreds of feet. GPS and laser guidance make World War II bomb sights seem primitive. But the Norden represented a revolutionary step in applying engineering to bombing accuracy. It attempted to solve ballistic calculation problems that human bombardiers couldn't solve quickly enough manually. This principle, automating calculations humans cannot perform in available time, defines much modern military technology. At the National Museum of the United States Air Force in Dayton, Ohio, a Norden bombsight is displayed in its vault-like storage case. The placard notes it cost $8,000 in 1940s dollars, equivalent to $140,000 today. More than many fighter aircraft of the era, the investment reflected American commitment to strategic bombing and confidence in precision over area attacks. Visitors examining the Norden often express surprise at its mechanical complexity. Gears, gyroscopes, mirrors, and dozens of adjustment knobs. No electronics, no computers in the modern sense. Everything purely mechanical and optical. The fact that such a device could calculate bombing solutions automatically while bouncing around in a bomber at 20,000 feet seems almost miraculous. A veteran bombardier, age 96, visited the museum in 2019. His comment captured both the Norden's promise and reality. We trained on Nordens for months. They told us we'd hit targets precisely. In training, sometimes we did. Over Europe, with fighters attacking and flak bursting, it was different. We did our best. Sometimes we hit the target. Sometimes we got close. Sometimes weather or fighters forced us to bomb through clouds at radar returns. No Norden involved at all. The sight was amazing when it worked, but it was just a tool. The mission's success depended on many things beyond the bombsight. Good planning, good flying, good tactics, good luck. The Norden helped, but it wasn't magic. That pragmatic assessment cut through the mythology surrounding the Norden. It was an excellent tool that provided real advantages, but it didn't make bombing easy or certain. It made bombing somewhat more accurate than without it, which was valuable but not decisive. The broader lesson is about technology and warfare. Sophisticated technology provides advantages, but warfare is too complex for single technologies to be decisive. Victory comes from systematic application of adequate technologies across all aspects of operations. The side with 10,000 good bomb sites, good bombers, good training, good tactics, and good logistics beats the side with 1,000 excellent bomb sites and deficiencies everywhere else. Germany understood the Norden's sophistication after examining captured examples, but understanding didn't help. Germany couldn't produce equivalent devices in necessary quantities. More critically, by 1944, Germany lacked the bombers, fuel and air crews to use such devices, even if they possessed them. The Norden exemplified American strengths: sophisticated engineering, mass production, systematic deployment. Germany couldn't match this combination regardless of how well they understood the technology. Baumbach survived the war, wrote his memoirs, and reflected on examining that Norden in 1944. In his 1956 book, he described his conclusion at the time: "I realized we'd lost the technological war when I examined that bomb site, not because it was so superior to our technology, but because Americans could afford to build 50,000 of them, and we couldn't. That disparity, repeated across every weapons system, meant Germany was fighting industrial mathematics as much as military tactics. Mathematics we couldn't overcome regardless of battlefield skill. The Norden bomb site didn't win World War II, but it symbolized the industrial and engineering capacity that did. In competition, whether warfare or business, sometimes the winner isn't who has the absolute best individual solution. The winner is who has good enough solutions deployed everywhere they matter. America had good enough bomb sites in every heavy bomber. That was enough.